Imagine a mining truck the size of a three-story building, moving hundreds of tons of iron ore across the brutal landscape of Western Australia's Pilbara and producing zero exhaust emissions, not a single puff of diesel smoke, nothing. That moment isn't coming someday, it's happening right now. And the three companies leading this revolution are the biggest names in Australian mining: BHP, Rio Tinto, and Fortescue. What they're doing with electric mining trucks is going to reshape the entire resources industry, and the story behind it is far more dramatic than most people realize. Let's set the scene. The Pilbara region of Western Australia is one of the most important stretches of land on the planet. It is the iron ore heartland of the world. BHP, Rio Tinto, and Fortescue collectively produce hundreds of millions of tons of iron ore here every single year. The trucks that haul that ore out of the ground are massive, some of the largest machines ever built by human beings. And until very recently, every single one of them ran on diesel. Enormous, jaw-dropping quantities of diesel. Here's the scale of the problem that these electric trucks are designed to solve. According to the International Energy Agency, mining operations account for 4 to 7% of global greenhouse gas emissions. That might sound modest compared to other industries, but when you do the math, it translates to billions of tons of carbon dioxide pumped into the atmosphere every year. And within mining, the single biggest source of on-site emissions is one thing: diesel-powered haulage trucks. Rio Tinto's Pilbara iron ore operations generate approximately 70% of their total emissions from diesel consumption. At BHP, diesel fuel usage accounts for around 40% of operational greenhouse gas emissions across their Western Australia iron ore division. Fortescue's mining fleet consumed approximately 450 million liters of diesel in their 2024 financial year alone, and that diesel accounted for 51% of their Scope 1 emissions. These aren't small numbers. These are enormous quantities of fossil fuel being burned every single day in one of the most remote regions on Earth to move iron ore from the ground to a port. So the question became unavoidable. How do you electrify the most diesel-intensive machines on the planet? How do you replace hundreds of liters of fuel per hour with a battery? And how do you do it in an environment where temperatures can exceed 45 degrees Celsius, cyclones tear through the landscape, and the trucks need to run around the clock, 24 hours a day, 7 days a week, 365 days a year? The answer, it turns out, required the three biggest miners in Australia to do something they had never done before. They decided to work together. In May 2024, BHP and Rio Tinto made a landmark announcement. The two companies, competitors in almost every sense, agreed to collaborate on battery electric haul truck trials in the Pilbara. They would each partner with a different equipment manufacturer. BHP would trial trucks built by Caterpillar. Rio Tinto would trial trucks built by Komatsu. And crucially, the outcomes of both trials would be shared between the two companies. Rio Tinto Iron Ore Chief Executive Simon Trott was direct about why this mattered. He stated that there is no clear path to net zero without zero emissions haulage, and that it was important for the industry to work together to get there as quickly and efficiently as possible. Then, in December 2025, the first trucks arrived. Australia's first Caterpillar 793XE early learner battery electric haul trucks were delivered to BHP's Jimblebar iron ore mine in the Pilbara. 2 trucks, but those 2 trucks represented something far bigger than their number suggests. They were the first battery electric haul trucks ever to be tested in the Pilbara. And the collaboration that brought them there, BHP, Rio Tinto, and Caterpillar working as one, was described as an industry first. BHP Western Australia Iron Ore Asset President Tim Day captured the moment perfectly. He said that powering up the first battery electric haul trucks in the Pilbara was an important step forward on the mining industry's road to decarbonization, and that replacing diesel isn't just about changing energy sources, it's about reimagining how we operate and creating the technologies, infrastructure, and supply chains to transform mining operations. Rio Tinto's Pilbara Mines Managing Director Andrew Wilson acknowledged the sheer difficulty ahead. Decarbonizing Rio Tinto's fleet across their 18 Pilbara mines, he said, is a significant challenge, but he was emphatic that no single company can achieve zero emissions haulage on its own. It takes the whole industry working together. Now, while BHP and Rio Tinto are still in the trial phase, testing, learning, refining, one company in the Pilbara has gone much further, and that company is Fortescue. Fortescue's commitment to electric mining is by any measure the most aggressive and ambitious in the entire global mining industry. In September 2024, Fortescue and German-Swiss engineering giant Liebherr signed what is described as the single largest equipment deal in Liebherr's entire 75-year history. The value of the partnership? Up to $2.8 billion. And what does that deal cover? 475 zero-emission machines, approximately 360 autonomous battery electric haul trucks, 55 electric excavators, and 60 battery-powered dozers. That's roughly 2/3 of Fortescue's entire current mining fleet being replaced with zero-emission alternatives. The centerpiece of this deal is the Liebherr T264 battery electric haul truck. This is not a prototype. This is not a concept vehicle. The first trucks have already been delivered to Fortescue's Eliwana mine in Western Australia, and the battery electric T264 commenced on-site validation at the end of 2025. The validation of the full autonomous battery electric solution is expected to be complete in early 2026. But here's what really blows the mind: the battery inside one of these trucks. Fortescue Zero, Fortescue's technology arm, developed a battery pack for the T264 that weighs 15 metric tons. It measures 3.6 meters long, 1.6 meters tall, and 2.4 meters wide. It's made up of 8 individually cooled sub-packs, each with its own battery management system. And the charging system that powers it? Fortescue developed a stationary fast charger capable of delivering up to 6 megawatts of power, charging the T264 in just 30 minutes. 6 megawatts! To put that in perspective, that is roughly equivalent to the instantaneous power draw of 6,000 households. Fortescue CEO Dino Otranto has been blunt about the financial imperative behind this transformation. He stated that fuel and energy costs are Fortescue's biggest operating costs, as well as their largest source of emissions. By electrifying operations, the company can tackle both simultaneously, and the numbers back him up. Industry analysts, including Gavin Mooney from energy software platform Colossal, estimate that Fortescue's electric fleet could save the company over $400 million in fuel costs every single year. $400 million annually. That is not a green vanity project. That is a fundamentally better business. But Fortescue didn't stop with Liebherr. In September 2025, the company announced it was expanding to a dual supplier model for its battery electric haul trucks. Fortescue signed a new agreement with Chinese equipment manufacturer XCMG, which is expected to supply up to half of Fortescue's future fleet of 300 to 400 zero-emission 240-ton haul trucks, with phased deliveries planned from 2028 to 2030. Fortescue also signed agreements with BYD for energy storage, LONGi for solar technology, and Envision Energy for wind power. The ambition? To power the entire electrification of its Pilbara operations with renewable energy. Not gas, not coal, renewables. Dr. Andrew Forrest, Fortescue's executive chairman and founder, framed the vision in characteristically bold terms. He stated that the world once benefited from open trade and cooperation, and that Fortescue is showing that industry can help rebuild that multilateral spirit, not through rhetoric, but through practical alliances that prove heavy industry can follow a new path, one where profits rise as emissions fall. Now, the electric trucks are extraordinary, but there is another revolution happening simultaneously on the same mine sites, and it is equally transformative. That revolution is autonomy. The convergence of electric trucks with autonomous operation is where the real future of mining is being built. According to global data, as of July 2025, Australia had 1,024 autonomous haul trucks in operation across its mining sector, up from 927 the year before. BHP alone operates 360 autonomous trucks. Rio Tinto operates 305. And between July 2024 and July 2025, the global number of autonomous haul trucks in operation rose from 2,080 to 3,832, an increase of 84%. That figure is expected to reach close to 5,000 by the end of 2030. At BHP's Western Australia iron ore operations, autonomy is already a reality at scale. BHP has reported that at South Flank, 10 trucks are currently operating autonomously, and the company plans to convert the remainder of the South Flank haul truck fleet in the near term. Newman East is already fully autonomous. BHP has stated that it is targeting approximately 85% of its haul truck fleet to be autonomous by the end of financial year 2027. And the safety results are remarkable. BHP has reported that autonomous trucks have resulted in 75% fewer collisions incidents compared to their non-autonomous mines. 75% fewer collisions. In an industry where a single accident can be catastrophic, that number is staggering. But perhaps the most dramatic demonstration of autonomous mining in the Pilbara, and arguably in the world, is at the Roy Hill mine. In October 2025, Hancock Iron Ore and Epiroc announced that all 78 haul trucks at Roy Hill had been converted from manual operation to fully driverless. 78 trucks running autonomously, controlled from a remote operations center located 1,100 kilometers away in Perth. The fleet comprises 54 Caterpillar 793F trucks and 24 Hitachi EH5000 trucks, two completely different manufacturers, all managed by a single autonomous system called Link OA. Roy Hill has become the world's largest fully OEM-agnostic autonomous mine. More than 250 million tons of material have been moved autonomously at Roy Hill. The trucks have safely traveled around 6 million kilometers, equivalent to going around the Earth more than 150 times. Insurance and risk management costs may also initially increase, given the novelty of the technology and the limited operational history of battery electric haul trucks at scale. And the carbon intensity of the electricity grid matters enormously. Mining operations in regions with high renewable energy penetration will achieve far greater real-world decarbonization than those still reliant on fossil fuel generation. There's also the workforce dimension. Transitioning an entire fleet to electric and autonomous operation requires comprehensive retraining. Technicians need new certifications in high-voltage safety protocols, battery system diagnostics, and charging infrastructure maintenance. The human element of this revolution is just as significant as the technological one. And yet, despite all of these challenges, the trajectory is unmistakable. The global competitive pressure is intensifying. China has already deployed over 100 fully autonomous battery electric mining trucks at a single mine, the Yimin coal mine in Inner Mongolia, developed by XCMG and powered by Huawei's 5G network. That fleet is planned to expand to 300 trucks within 3 years. Australia cannot afford to fall behind. The EU's Carbon Border Adjustment Mechanism, which began applying carbon pricing to high-carbon imports in January 2026, adds approximately 80 to 120 euros per ton to carbon-intensive products entering Europe. This creates a direct financial incentive for Australian miners to reduce the carbon footprint of their operations if they want to maintain access to European markets. Green steel initiatives are similarly incentivizing low-carbon iron ore. Analysts project that by 2025, up to 25% of copper contracts will include carbon footprint specifications. The market is pricing carbon, and the companies that can demonstrate genuine emissions reductions, not promises, but proof, will command premiums. So where does this leave us? The electric mining truck revolution in Western Australia is not a future event, it is a present reality, unfolding right now at a pace and scale that is genuinely historic. BHP and Rio Tinto are testing the technology in Pilbara conditions for the first time, sharing data and building toward scaled deployment. Fortescue has committed US $2.8 billion to a fleet transformation that will replace two-thirds of its mining equipment with zero-emission alternatives by 2030. Roy Hill has shown the world what fully autonomous mining looks like at scale. And the renewable energy infrastructure to power all of it is being built, solar panel by solar panel, wind turbine by wind turbine, battery by battery. Caterpillar has set a public target of deploying over 2,000 autonomous mining trucks globally by 2030. The global autonomous truck fleet is already approaching 4,000 machines and growing at a rate of over 80% per year. The convergence of electrification, autonomy, and renewable energy is not a theory, it's not a pilot program, it's becoming the standard. The diesel age of mining is ending, not because anyone decided it should end overnight, but because the economics, the technology, the climate imperatives, and the competitive pressures have all aligned simultaneously to make the transition not just desirable, but inevitable. BHP, Rio Tinto, and Fortescue are leading that transition, and the electric mining trucks rolling across the red dust of the Pilbara right now, they are the proof that the future of mining is already here.